Welcome to Lesson 3 of Module 1, Topic A, Ratios and Proportional Relationships. Now in this lesson and lessons to come, the main idea or the main topic is identifying proportional and non-proportional relationships in tables. And I'm going to kind of hurry through this one, and just to kind of cut to the chase. I get a little weary with some of these lessons looking forward. Now with this one, as you can see, let's just look at classwork example 1 here. You have been hired by your neighbor to babysit their children on Friday night. You are paid $8 per hour. Now that $8 per hour right here, and that is the key to knowing the answer before you even fill in this table, okay? It says complete the table relating your pay to the number of hours you worked, okay? So if you go ahead and you look at it, and so if you're paid $8 per hour, you work 1 hour, right here, your pay is going to be $8, okay? Now, you guys could figure out the rest. You work 2 hours, 16. Okay, so what we're looking at this relationship, this constancy over here. What do we multiply? We multiply 1 times 8 to get 8, 2 times 8 to get 16, etc. Okay, the only one that on this chart that could have, or this table that could be of any challenge to you might be 4.5, but hey, 4 times 8 is 32. 1/2 of 8 is 4, so 36. This one right here, okay, and if that looked like, 36. Okay, 36, and again, you could fill in the rest. You know, what they want me to ask you at the end is, based on the table above, is pay proportional to hours worked? Of course it is. Of course it is, because you are paid $8 per hour. Per hour. Each hour. Okay, so if you're paid per hour each hour, there's always going to be a proportional relationship there, a constancy. You're always going to multiply number of hours worked by 8 in this case to get your pay. Okay, and that's before taxes, of course. So anyway, let's move forward. And so if we go ahead down here, that's that question right there. Now for exercises 1 through 3 here, they want you to determine if y is proportional to x. Okay, now what they've done here, now they've kind of introduced you to this. I'm sure you've seen this before. This idea of x and y, 2 variables. You're going to see this more and more often as we move forward. But one thing that miffs me a little bit about this table that they've created for you here is that in this case, well, actually in the last case, let's go back to that. Let's go back to that last one. Okay, this last table right here. Okay, in this case we have hours worked and pay. Okay, that's all we need. Those are the only 2 values, or only 2 numbers we need. Now in this case down here, a little bit, just bugs me a little bit, because in this case, what they're doing here is they're asking you this. So I'm going to go ahead and read this. The table below represents the relationship of the amount of snowfall. Okay, this is the amount of snowfall in inches in 5 counties. Okay, now this is 5 separate counties, let's say in some state. Okay, so this table here is representing the relationship between the amount of snowfall in 5 counties to the amount of time of a recent winter storm. Now truly there should be another column here. Let's just say county, just so you know these are just 5 different counties. And we'll talk about why later, why this is so County 1, County 2, whatever, okay? How this is so different from the other one and ones to come, okay? So, here we go. We can look at it. If you want to, go ahead and stop, and you take a look at it. You see if there's any proportional relationship here, y to x, and then turn it on, and I'll be talking again. And I just paused there in case you wanted to pause. But anyway, I'll continue here. So if we go ahead and look, we have how many hours over here? 2 hours. Okay, 2 hours of snowfall and 10 inches of snow. Okay, and what is that little multiplier there? Is of course 5. Okay, because 2 times 5 equals 10. Okay, so 5 inches per hour in County A, let's say. The next county, County B, you had 6 hours of snowfall, and you ended up with an accumulation of 12 inches of snow. And there, if we did the division, 12 divided by 6, that's 12 inches, divided by the 6 hours, we have 2 inches per hour. Okay, and then if we go on, we see in County C, that same 2 inches per hour. In County D, 2 inches per hour, that's 5 inches in 2.5 hours. And then in County E, 14 inches in 7 hours. Again, all of those are 2 inches per hour. Now, if it wasn't for this one being different, we could say that this table does represent a proportional relationship. Okay, and for me, I think it's a little bit silly. This whole, they want you to see that ratios are not always proportional. Okay, so I guess what they're saying here, what they're really saying is that, there was probably a more sustained, or actually a more, greater amount of snow fell in little time in County A, up here where it snowed 4 inches per hour. But even if it was proportional, you can't use that number to predict. Okay, you can't predict what was going to happen in County F, for example, or you can't even predict what's going to happen in County A in next month or even next year, exactly this time. Okay, whereas what's different is that with the first case here, okay, here you're getting paid $8 per hour. Okay, if your pay stood stagnant, okay, usually you don't get raises, constantly. Maybe to get a raise in a year, but you could pretty much count on, if you work 4 hours, you're going to get $32 today, tomorrow, next week, next month, probably a year from now. Okay, so that's how those are different, and I'm not sure. I hope I didn't confuse you, but in that case, anytime you have a situation where you're going to get paid per hour, of course it's going to be proportional. Okay, and here's another one that's similar, and don't need a lot of time to spend on this one either. Okay, here's the situation. The table below shows the relationship between the cost of renting a movie in dollars to the number of days the movie is rented. Okay, it's pretty straightforward. 6 days you rent it, $2. Okay? What's our multiplier here? Number of days, $6. 6 days, the cost, $2. Figure that one out. Then we have 9 days, $3. 24 days, $8. 3 days, $1. Okay? So in this case, they've kind of given it away. Our multiplier, of course, is 3. okay, times 3. So for every 3 days, and you can see this actually in this last one, the last situation, for every 3 days, the movie costs $1. So it's $1 per 3 days, okay? $1 each 3 days. That is the cost of a movie at this movie theater, at this movie rental, okay? And again, you can see the question, is this proportional? And the answer would be yes. Okay, that's a proportional table. All right, another one, number 3. Number 3, the table below shows a relationship between the amount of candy bought in pounds and the total cost of the candy in dollars. Okay. Now there is the case very often where you get quantity discounts when you're buying something. Candy in bulk is not usually one of those. So if you go ahead and you look on this table, I'm sure you can see just by perusing it really quickly, you can see that there is indeed a proportional relationship here, as you have 5 pounds of candy costing you $10, and you can just see it consistently, 4 costing you 8, 6 costing you 2. You can just see the number that consistently comes between the cost and the number of pounds, and that would be 2. Okay, so times 2. Therefore, this candy costs $2 per pound. Okay, which doesn't sound like a really bad deal. Okay, so in that case, that one is as well proportional. Hopefully, you guys are getting this. If you don't, you could always call. There'll be a practice set, a problem set to go along with this one. Here's number 4. Randy is planning to drive from New Jersey, that's my home state, to Florida. Every time Randy stops for gas, he records the distance he traveled in miles and the total number of gallons used. Okay? Assume that the number of miles driven is proportional. So now we're making this assumption. Now we're assuming proportionality. Okay? Assume that the number of miles driven is proportional to the number of gallons consumed. Okay? We are. And this is probably would be relatively unrealistic if you, once you start to drive a car, how you're driving or the conditions you're driving under do change. But if you are driving consistently, you can get a good consistent what we call miles per gallon. Okay, miles per gallon. But let's go ahead and look at it. Okay, if we're going to assume the proportionality of these two, then we can see we'll use what we know, and always using, of course, on this table right here, we're going to see that 2 gallons were consumed for 54 miles driven. Okay, so if we look at that one, then we would have to, of course, we would divide 54 by 2. Okay, because if you looked at it, I don't know if we said we had a number line. That was 0. That's 54. Okay, miles. Right here, this whole thing took 2 gallons. Okay, so 2 gallons. So if that took 2 gallons, 54 took 2 gallons, we would know that half of that, or 1 gallon, right here would have been 27, and that's just dividing 54 by 2. Okay, so in this case it's 27. All right, if we did the division here, 216 divided by 8, okay, we would get that same answer, 27. So in this case we are getting 27 miles per gallon, which is a decent fuel efficiency, I would say, because depending on what you're driving these days. Okay, so again, if you filled in this chart, and that's all they're asking you now. They're not asking you if it's proportional. They're telling you it's proportional, and they just want to see, or I want to see, that you can fill in this chart. So I would have you go ahead and just fill this in yourself. Do the math. Right here, you're going to do 4 times 27. Now, what would you do here? If you already had the miles driven, what would you need to do? Thinking about it? I'll let you know in a minute. That's right, you would use division, okay? Because in this case, you already know the miles driven. So 189, we've already figured out the miles per gallon, okay? All right, and if we did that, we would, what would we come up with? We would come up with, that's 7, yeah. Okay, 7, because 7 times 7, 49, and then 14, 189, yeah, so 7. So this would be 7 here, okay, and this, of course, right here, it's, it's 2 times that to get there, and 2 times this to get here would be 108, okay? So, anyway, you can go ahead and finish that one, but again, they're just want to see, checking in, see if you can fill in this chart. Okay, so if we go down, all right. So pretty much just this. That was it's a quick lesson. Maybe you just go ahead and take some time on the problem set that follows. And what they want to know is, as you can see down there in each table, 1, 2, and 3, determine if y is proportional to x. Explain why or why not. But before you do that, let's just go ahead and go over this this lesson summary right here. Again, and we've said this many, many times, but one quantity is proportional to a second if a constant number exists such that each measure in the first quantity multiplied by this constant gives a corresponding measure in the second quantity. Okay, and all those very, very big words. Let's just go ahead and go back. Good to get used to these big words, though. Go back, and right here, like we said before, what's our constancy here? Our constant number is 2. Okay, oops, I don't like that one. Okay, our constant number is 2. All right, 2. Everything, you multiply x times 2, so 2x in this case equals y. Okay, here's our x, here's our y, and again these relationships or equations. Okay, we're going to do more and more in the future. Okay, so let's go back to our lesson summary. Okay, yeah, so lesson summary. Here we go. So steps to determine if 2 quantities. I am right here. Okay, so steps to determine if 2 quantities in a table are proportional to each other. And again, it's pretty basic if you look at it, but here's a guide anyway. For each given measure of quantity A and quantity B, find the value of B over A. Okay, that's like we just did with the candy and the pounds. Okay, if you divided the number of how much it costs by the pounds, you'll get the price per pound. Okay, and then if the value of B over A is the same for each pair of numbers, then the quantities are proportional to each other. And again, let's just go back and look at that. Let's read that statement again. If the value of B over A, again, I'll just underline this while we're doing it. This is what I'm looking at right here. Okay. If the value of B over A is the same for each pair of numbers, then the quantities are proportional to each other. Okay, so let's go ahead and let's go back. Let's just look at that just one more time. This right here. So here we go, B over A. Okay, so let's say we have, in this case we have Y. Let's say B over A or Y over X. Okay, so the first one you can see is 10 over 5. Okay, that's this case right here. And then we have to say that is equal to 8 over 4, which is equal to 12 over 6, which is equal to 16 over 8, which is equal to 20 over 10. And again, I'm using all of these values here to get these fractions or ratios. And all of these, 10 over 5, 8 over 4, 12 over 6, 16 over 8, 20 over 10 are all equal to 2. Okay, and that's our unit, in this case, a unit price. Okay, $2 per pound. Okay. Okay, kind of jumped up around here and there to do this, but hopefully you get it. Again, they just want you to see what's proportional, what's non-proportional, and we will be doing that same thing. Looking forward to that in actually lesson 4 again, looking again at tables. Okay, so again, go ahead and do that problem set and your exit ticket, and then look for lesson 4 coming your way. Okie doke. All right.